Good afternoon, everyone, and welcome to the next webinar in our new series, Bringing Data to Life. My name is Eleanor, and I work at the Office for National Statistics. We're delighted to see so many of you join us today for our beginners webinar on artificial intelligence and innovation. Before we start, we'd like to remind you that all the webinars in this series will be recorded and will be available on YouTube after the event. The slides and recordings for our first 4 webinars are now available on the ONS website. Everyone signed up to this webinar will receive a link once today's recording is available. With so many of you joining us on the call today, the chat function is closed and all questions will be facilitated through Slido. I'll cover this in a bit more detail in just a moment. This webinar series is for everyone, so please share the recording and slides when they're available and join the conversation on socials using the hashtag #StatisticsForThePublicGood. Lastly, you will be invited to complete a short survey at the end of the webinar, and we'd really welcome your feedback on the webinar series and statistics we produce. We have launched the next phase of webinars and we'll be covering some exciting topics in 2025. You can sign up to the next webinars by going onto the Bringing Data to Life collection on Eventbrite or scanning the QR code on your screen at the moment. So the session today is interactive with some questions for you, and there will be a Q&A section after the presentations. For those who have attended previous webinars, you'll notice that we have set this webinar to 1 hour instead of 45 minutes to extend our Q&A section. This has been decided based on feedback from attendees, so thank you to those who have attended our previous sessions. Please join in by scanning the QR code on your screen or heading over to slido.com and using the number 2652349. If you're using the desktop Microsoft Teams app, you can click the S Slido button at the top of your screen and Slido will appear. The Slido code will appear on every slide, so don't worry if you miss it. I'm so pleased to welcome our speakers today. We are joined by Fiona James, Chief Data Officer and Director of Data Growth and Operations at the ONS. Fiona will explain what is AI and how the ONS are piloting its use. We're also joined by Sarah Stevens, Director for Disease Registration at NHS England, who will explore how AI is being used for early cancer screening. This section will start at around 15 minutes and will mention cancer treatment, so please feel free to take a break or step away during this section. I would now like to hand over to Fiona.
Welcome, my name is Fiona James, and we're going to start off with what is innovation? What are the definitions of artificial intelligence and how does ONS approach its use? So innovation is very much a concept, it's a way of working. It's all about kind of new idea generation, and it's not about really what it is. It's about how we apply it day to day in our daily lives. The UK's artificial intelligence market is expected to grow to 788 billion by 2035. The UK already has an artificial workforce of over 360,000, and Britain has twice the number of artificial intelligence-based companies than any other European nation. The technology has moved at an unprecedented rate, with influential commentators recently saying that artificial intelligence has exhausted available real-world training data, advocating for synthetic data generation. And since the launch of ChatGPT in November 2022, hundreds of artificial intelligence tools have begun making their way into our lives at home and in the workplace. And these range from writing tools through to voice generators and art generators. And when we look at the top 5 most downloaded artificial intelligence apps from January to August last year, these were ChatGPT, Remini, PhotoRoom AI photo editor, Google Gemini, and Daobao, which is a Chinese app. So you can see these are very much in the area of photography, image, and enabling us to use our time more effectively. And you can see others here on the slide, which you might be more familiar with from a work perspective, like Copilot or Bard, for example. So artificial intelligence is the umbrella term that encompasses all the subfields of artificial intelligence. That means creating systems and machines which perform tasks that typically require human intelligence. Machine learning is a subset that involves the use of algorithms and statistical models to improve performance on a specific task. Deep learning is a subset of machine learning, which is a specialized tool particularly good at working with unstructured data like images, audio, and text. And then you have generative artificial intelligence, which is the newish element because it creates new content or data that is not explicitly derived from existing examples like generating text, images, music, and much more. Large language models are a specific application of generative artificial intelligence, specializing in natural language. And training a large language model can be a very expensive process that can cost tens of millions of pounds in hardware and electricity costs alone. But pre-trained models can be fine-tuned on smaller, task-specific, curated data sets, which helps the model to perform better on that particular task. And I'll talk a little bit more about that later. So firstly, we wanted to start by asking you, which AI tools do you use on a daily basis? So that's really interesting, isn't it? Because there's a massive range of different tools there that you all seem to be using, but with quite a chunk using Copilot and ChatGPT. So let's move on to ONS's artificial intelligence strategy, which is very much part of our overall data strategy. So there's really three buckets to how the UK government and ONS is approaching the adoption of artificial intelligence. On the 13th of January, the UK government published the Artificial Intelligence Opportunities Action Plan, setting out the government's focus on economic growth, improved public services, and increased personal opportunities. The plan covers three elements. So firstly, investing in the foundations of artificial intelligence, needing world-class computing and data infrastructure, access to talent and regulation. Secondly, the cross-economy artificial intelligence adoption, that the public sector should rapidly pilot and scale AI products and services and encourage the private sector to do the same, driving better experiences and outcomes for citizens and boosting overall productivity. And thirdly, positioning the UK to be an artificial intelligence maker, not an AI taker. Be the best state partner to those building frontier AI, working to identify true national champions at critical layers of the AI stack so that the UK benefits economically and we are able to influence the future kind of values, safety and governance. Now, this all builds on the previous government's work to develop AI for safe, responsible and transparent use, which focus more on principles, regulation and capability building, especially through an AI Safety Summit, which happened in 2023. As head of the analysis function, the ONS is coordinating efforts across government analysis alongside the Department for Science, Innovation and Technology, who are responsible for AI policy. The analysis function is focusing effort on building capability, leadership, and providing strategic methodological direction. For example, we have recently conducted a cross-government stocktake, established an analysis function AI steering group chaired by Sir Ian Diamond and Dame Angela McLean, which is considering future AI scenarios, the impact on the labour market, the impact on public sector productivity, and AI risks and safety. Now, within ONS as an organisation, and I'm sure this will be the same for the organisations that you work in, there are strong drivers to use AI and large language models to drive productivity and efficiency, where we have identified around 20 evolving opportunities to progress work. And it remains our core responsibility that we continue to put trust and equality at the heart of our statistics and data. And we're very clear that our focus is primarily on our circle of core responsibility, where we can use new tools to be better. So instead of rushing off and developing an AI strategy, we're first seeking to test the AI to review the problems, develop our knowledge, and empower colleagues to learn. We've taken the view that any pilot application must be closely monitored. The technology is unfamiliar, and the misuse of tech, either accidentally or on purpose, may lead to adoption setbacks, and there are uncertain costs associated with it, including both maintenance cost and environmental sustainability impacts. Anything drafted by a large language model needs a human in the loop to ensure that the context is correct and doesn't represent a biased point of view. They aren't designed to verify that content is factual or necessarily the best choice. Instead, they are very good at understanding textual information, summarizing large amounts of data and generating human-like responses, which can be useful in automating many tasks. So the top 20 evolving opportunities that we've identified to use AI broadly fall into these three buckets that you can see in front of you. The first is around data processing and preparation and quality assurance. So looking at code conversion, debugging code, automatically classifying dense text to statistical classifications, educational and training purposes, and generating metadata. Secondly, using it to improve internal operational processes, so supporting with generating emails, preliminary reports, templates, presentations, retrieving and summarizing information and comparing content, like, for example, a HR chatbot. And thirdly, external communication, so improving the content for our users, summarizing, personalizing for different audiences, helping with Q&A, data visualization and data dissemination. So we've developed this into around 9 pilot projects where we're evolving our understanding. Now, I'm not going to talk to each of these projects, but I will touch on 1 or 2 of them as we kind of move through today's presentation. And most of our piloting up until now has fallen into that first bucket around data processing and preparation and quality assurance, which is not unexpected, as you'd find for a National Statistics Institute. But before I share some of our learnings, I'm really honoured to be joined by Sarah Stevens from the NHS to share a real-life public service operational example of how AI is changing and improving lives. So I'll now hand over to Sarah.
Hi there. Thank you, Fiona. Thanks ever so much. It's great to be here. So I'm a public health consultant leading the National Disease Registration Service. My next slide is going to take you through what NDRS does. So we collect patient data on all patients with cancer, congenital anomalies, and around 2,000 rare diseases in England. We're an end-to-end service, which means that we collect data from the start of the patient journey, journey in secondary care, so that referral into the hospital, and we follow the patient through their pathway, collecting information on their diagnosis, on diagnostic testing, on treatment, and on follow-up. And this is across the patient's life. So any recurrence of cancer or further cancer diagnosis, and we follow up across that life course. So this can be in the region of 450 different data items for each patient. And the information comes from across the NHS. So there's around 162 different healthcare providers and 500 local data systems. Hospitals will often have different systems for different aspects of their care. We have trained registration teams that piece all of this information together, and it's held in a secure data management system that we have built in-house. So this information then, as you can see on the slide, is shared back with clinicians to inform the care of their patients, and it's also used for quality improvement and audit. It's used for population health, So we produce over 100 routine reports, many of which using ONS births and deaths data, so to produce official statistics on new diagnosis of cancer each year, how many people are living with cancer, survival by cancer type. We also use the information for planning and commissioning of services within the NHS. So that's providing benchmarking information, evaluation of treatment interventions. And we then support research and innovation. Excuse me. So we've contributed to over 300 peer-reviewed publications to date and have a number of partnerships with academic institutions, with universities, charities such as the CRUK and Macmillan. So the example I'm going to give fits into that first bucket that Fiona was talking about around data processing, data preparation and quality assurance. So we have developed a data submission portal. It's an in-house extract, transform, load, so an ETL engine to ensure that data from all of these different disparate sources can be received and processed in an accurate, consistent and safe way. So there are 3 ways to submit data: through an upload, a web form or an API. And data comes in from all of those different data notifiers, so from hospitals and laboratories, clinics across the NHS and private providers where they're providing NHS care. Prior to 2006, when this was launched, data used to be submitted via secure email or really cumbersome kind of secure file transfer methods. And actually not long before that, data was still coming in via paper. So why is it so innovative? So previously, there was no immediate feedback on the data, and the portal now provides real-time feedback to the notifier without any staff intervention our side, and reduces the workload for frontline staff as well, frontline clinical staff. So this isn't only on validations, of which there are about 1,000 across the 14 different data sets, but the portal also lets notifiers know whether their data makes sense. So an example for this would be that most cancers are staged, and that's described the size of the tumour and how far it's grown. And we can tell a notifier if they've staged all their cases that they're sending. It facilitates ownership of the data by notifiers, which we've seen an improvement in the quality and completeness of submissions as a result. And the scale and the volume of the workflow for us is great. So to date, cancer records on over 2.1 million patients have flowed through the portal, with genetic testing and congenital anomaly notifications in addition to that. But what it has enabled us to do, which I'll go on to talk about just now, is that we have this infrastructure, this fantastic infrastructure in place, and we can build on top of that system to enable delivery and to do that at pace. And that's how we've been able to establish a Lynch syndrome registry. So Lynch syndrome, excuse me, is a rare genetic condition that increases your risk of some types of cancer, including bowel cancer. So back in December 21, the NHS National Bowel Cancer Screening Programme approved a proposal to add early identification for Lynch syndrome patients, so an early entry into the bowel cancer screening programme. And you can see on this slide, the recommendation is that they join at age 25 or 30. Now that is in difference to the general population, where invites generally start at age 60. So the problem now is how to accurately identify patients and invite them for targeted screening. And so the submission portal that we have developed enabled us to build this registry and develop this new service through timely invitation to patients in just 30 developer days. It takes out the manual creation for our registration staff so that our registration staff can focus on the more complex cancer registration, and it enables this to be fully automated. And to our knowledge, we're the only country in the world that has a national Lynch register and is also using it in a way to be able to invite patients for screening. So in terms of the impact on patients, since its launch in July 2023, we have this real-time data collection, so we have no lag. And there's a daily data exchange with our screening IT systems. So every 24 hours, patients are there's an exchange, which means patients are invited for bowel cancer screening. In just over 1 year, we've invited 7,300 patients, and 6,000 of those so far have attended screening services. Just over half of those have had diagnostic testing. And the outcomes of that, we're following up really, really closely, and we'll be publishing in time. But we, of course, do know that early detection of cancer saves lives. The next slide just shows just how well this change in service has been received by patients and their families. So this is taken from some immediate social media response that we've received. Okay, so what next? So work is underway currently to expand the Lynch Register to a National Inherited Cancer Predisposition Register. So that's for all known genetic conditions that increase your risk of cancer. And that's a commitment that we've made in the England Rare Disease Action Plan. You can see the document on the slide there. That will also include those that are very high risk of breast cancer. We are also exploring the use of AI, looking at, in particular, a coding bot. So using guidance from coding and classification, both on procedure codes, so what intervention you have in hospital, and also on diagnostic codes, using the International Classification of Diseases, and using guidance nationally across England to look at how we can automate, use AI to speed up that process. We're also using it in particular in large language models. Now that we have National Cancer Registration Service in place and we have a wealth of data there, looking at how we can use that, as Fiona says, to train those models. Particularly, we're interested in pathology reports where we still do get a lot of information from free text. So it's structuring that information in a way that will enable us to be much more efficient. And then, as I hope I've demonstrated through the Lynch syndrome registry example, the timeliness of that, in speeding up the timeliness of that, has a real impact on our ability to improve direct care and improve patient outcomes. So I just want to say a huge thanks. Oh, before I do say a huge thanks, I'm going to just take a pause. And there's a question here about how you feel artificial intelligence could be used to improve people's health more widely than the example I've just given. Okay, thank you ever so much for the input there. It's obviously something that we do, there's lots of opportunity for it, and it's making sure that we're doing it in a way that ensures accuracy and security across the data that we hold. And just to say a big thank you to everybody involved from an analytical and technical aspects, and also the clinical involvement too. I'll pass back to Fiona. Thank you.
Thank you very much, Sarah, and absolutely fantastic. I could see all the hearts and the claps there coming from you all, which is absolutely fantastic. It really shows the value of having the data foundations in place to really save people's lives. So well done, and I'm really pleased to have been joined by Sarah. Thank you very much, Sarah. Okay, so we're going to move in now to just delve a little bit deeper into the things you need to know if you're using artificial intelligence. So generative artificial intelligence speaks to you like one of your friends. The way that it's able to communicate in your own language is very powerful and convincing. It also helps us to communicate and be more creative. So for example, DALL-E is being used to create high quality text and images, just like I've done on this slide, but with Copilot. In marketing, it's used to create personalized content, optimize advertising campaigns, and in the music and film industry, it's even being used to produce music and even write scripts. These examples highlight the diverse application of generative AI in enhancing communication. Now, the widespread application of machine learning, particularly deep learning, has led to the development of highly accurate models that unfortunately lack explainability and interpretability. Now, explainability and interpretability are often used interchangeably. Explainability is really about why AI models make their decisions, whereas interpretability is how the models make their decisions. Primitive machine learning models such as linear or logistic regression and decision tree are far less accurate but more easily explained. However, as we know, real-world data is highly non-linear and complex, and this makes processing it to gain knowledge and insights a real challenge. Under these circumstances, deep neural networks are exploited to extract information from highly complex data sets. And after using deep neural networks, scientists have realized that a deeper network is better for decision making than a shallow network. Moreover, to extract patterns from this kind of very complex data, a sophisticated deep neural network must be trained on a large data set, and by increasing what are known as filters and other things, it can lead to a highly complex but highly performant AI model. Now, due to their complexity, unlike other machine learning techniques such as decision tree or fuzzy rule-based systems or Bayesian networks, a decision from a deep neural network is difficult to fully understand and trust. And due to these hurdles, there is a problem. And we refer to this problem as the black box conundrum. The black box conundrum in AI therefore refers to a system's difficulty in offering a reasonable explanation for how the system arrived at a decision. As this slide shows, the words black box, grey box, and white box are used in computer science and engineering to refer to varying levels of closure of a system's internal components. So the grey box model, which applies, for example, to Bayesian networks, are models that users can interpret at some degree if they are carefully designed. White box models are known as interpretable by design, thus making their outputs easier to understand, but far less accurate. On the other hand, black box models are more accurate, but less interpretable. So the bottom line here is that in order to be able to explain or interpret AI, really, we should be able to explain the quality and present enough information relevant for the context or use case. So explanations, for example, for developers may very well be different for those for regulators that might be different for the end user. So now we're going to go back to you and ask what common areas have the potential to go wrong with AI. Very good. So it's really interesting to see that we've got quite a good knowledge in the virtual room, so to speak, of the set of common areas where really, while AI has massive potential, you need to be aware that it can provide misleading or incorrect facts or information, and you need to be especially wary when you want to achieve high accuracy, as I have explained. So hallucination. Generative AI can sometimes generate information that's based on any real data. This phenomenon is known as hallucination. It can lead to the creation of entirely fictitious content that appears plausible but is inaccurate. Some of you might have seen that the BBC complained this month after an AI-generated summary of its headline falsely told some readers that Luigi Mangione, the man accused of killing United Healthcare Chief Executive Officer Brian Thompson, had shot himself. These AI summaries by Apple do not reflect, and in some cases completely contradict, the original BBC content. Bias and unfairness, I could see a number of you were calling that out. Due to fundamental biases in some datasets and algorithms, some groups of individuals can be treated unfairly and discriminated against by AI systems. Fairness refers to a model's ability to make unbiased decisions without favouring any of the populations represented in the input data distribution. This can lead to racist and hateful content. Less than a day after she joined Twitter, Microsoft's AI bot, Tay.ai, was taken down for becoming both sexist and racist. Prompt injection. Malicious users can exploit AI by crafting inputs that manipulate the model into generating harmful or unintended outputs. This can be a significant security threat in open-ended communication systems, where models might reveal private information, spread misinformation, or give unsafe advice. Context misunderstanding and appropriateness. Generative AI might misinterpret the context of a conversation or query, leading to responses that are irrelevant or inappropriate. This is particularly challenging in nuanced or complex discussions. For example, in late January 2024, sexually explicit, inappropriate, AI-generated deepfake images of American musician Taylor Swift were proliferated on social media. So while you cannot fully mitigate these risks, there are some foundational steps you can take which will support you explain the AI model, as we've already covered, but also what data is being consumed by AI. Now, improving the quality of the input data is absolutely critical, and we can do this with metadata. The quality of the input data will be critical to the performance of AI and the effectiveness of any search and retrieval. Metadata can help reveal the origin, meaning, and relationships between data points, allowing your AI models to understand the bigger picture and make more accurate predictions. For instance, knowing that a particular data set is from a specific time period or geographic location can significantly enhance the relevance and accuracy of AI-driven insights. Metadata can also help to track AI model versions, performance metrics, and deployment settings. So imagine a chef trying to cook with mystery ingredients. Metadata provides the information about the structure and the format of your data, enabling cleaning, engineering, and linkage, the essential data preparation work for AI training. And metadata effectively acts as the recipe book, ensuring that the data is prepped and that it is ready for models to consume and learn from. Now at ONS, we're going further than improving the quality of our data, and we're developing a common data model. There's a vast amount of data that's potentially available to analysts to enrich their research to provide benefit for the public good. And this data comes from a range of sources, for example, administrative or alternative data, through to survey data, which is collected directly. And knowing if and how different data sets may piece together to inform research can be very difficult. So we're working to categorize the content and meaning of data sets in a common way. This will enable tools for analysts to be able to quickly identify novel uses of diverse data and to produce outputs quicker. The visual here represents an example dashboard that could be provided to analysts with fictitious data content. It shows 4 original columns that are logically defined by property type, for example. Now, achieving this metadata curation is difficult manually due to the sheer number of data sets and the number of variables within them. Often each will have hundreds, sometimes thousands of columns, and this approach doesn't scale very well. Large language models' capabilities can be used to automate and improve metadata augmentation, making data more discoverable, usable, and understandable. And we're currently testing the use of AI to help with providing meaningful categorization of dataset content and intuitive naming of variables. So just briefly to show an example of how we've built our understanding of both data and an AI model, I'll briefly share this use case. So we identified an opportunity to use a large language model to classify free text responses from our surveys into our data operations in order to see if we can improve the quality. In particular, we wanted to explore the difference between using an existing algorithm or a kind of auto-coding approach against the large language model approach. So currently we use this auto-coding machine learning algorithm to provide a matching service internally to part of our business, which produces economic classifications and which then supports economic statistics. And we create something called a classification index, which is part of how we identify and assign statistical data according to economic activity like agriculture, mining, construction. The matching service works with the index and makes sure that we're correctly identifying individual business units from multiple sets of data that we have about businesses. And we need to try achieve a very high quality for our matching. So we aim for a 99% matching rate, giving us complete confidence that we have the right business unit. So we implemented a large language-based classifier using Google's latest large language model, Gemini Pro, into a Google Cloud Platform environment in order to test the accuracy of this new model using real-life training data with clerically coded responses, and then testing how that fine-tuning was working in real life. And we looked at the match rate, so the coverage, we looked at the matching accuracy, so the precision, and we looked at overall accuracy. Now, when it came to the one-to-one matching, we saw a 5% increase in the matching accuracy with the large language model for the 2- and 5-digit standard industrial classification levels, respectively. And the marginal gain was greatest at the 5-digit level. But our existing algorithm actually performed better at the bulk matching, which suggests that the generative AI for this particular context and for this particular use case is better able to adapt to specific input data. So this has really helped us evolve our learning to consider bespoke or kind of hybrid approaches when using both large language models and existing machine learning. But it's also helped us evolve a new application called Classive AI for our other survey operations, where we assign free text to a set of categories. We've recently made this methodology and code available publicly, and this work has had remarkable interest internationally, with numerous other national statistics offices around the world requesting to work with us, including the US Census Bureau, who have been actively testing the code base, Ireland, Statistics Singapore, and Statistics Sweden. And we've also presented this work in a number of forums, including the United Nations and the OECD. Right, let's move on in a little bit more detail to the importance of human decision making in all of this. Because the over-reliance on AI without adequate human oversight can lead to errors and unintended consequences, and it's essential that we keep the human in the loop to ensure that AI outputs are reviewed and validated. So obviously the tech is one thing, but ultimately it's the decisions about its use which are important. So how do we go about making decisions? Well, firstly, for most organisations, I suspect that we now have a set of AI principles which provide the guidelines for the use of AI. And here on this slide, you can see what the ONS's AI principles are. I'd particularly call out number 4, you use the right AI tool for the job, and number 6, you ensure statistical quality is sufficient. You consider how the AI deployment affects the quality of the analysis and make sure that the outputs are fit for purpose. Across government, a national AI strategy was published in 2021, alongside an algorithmic transparency reporting standard to put public engagement at the heart of the approach. The Generative AI framework was published in January 24, and following the AI Safety Summit, the UK signed a landmark deal with the United States to work together to test AI safety. In terms of policies, we have implemented 2 new policies within ONS in order to make sure we've got the right corporate guardrails in place. So the first is the AI policy, which sets out how we expect our people to behave in terms of acceptable and responsible use of AI. And secondly, an enhanced security policy to ensure we maintain data security when using AI. It's worth being aware, though, that the AI principles are developing. Ethics is also a big part of decision-making in the use of AI. Medical AI systems raise unique ethical issues related to patient safety, informed consent and privacy, which may require different technical and legal frameworks compared to, say, finance or transport. There's been recent calls for frameworks and guidelines for ethical AI design and deployment, such as UNESCO releasing a global agreement on the ethics of AI in 2021, and the EU ethics guidelines for trustworthy AI. And this follows the European AI Act, which aims to ensure quality and trust to enhance industrial and research capabilities while upholding the fundamental rights of citizens. Spain, for example, have already established a new supervisory AI authority. One ethical issue that crops up over and over again is the impact on the workforce. There will undoubtedly be effects on AI on the future of the workforce. AI systems must be innovative, trustworthy, and respectful of human rights. But the possible impacts are multifaceted and can be seen from various perspectives. AI is expected to create new jobs while displacing existing ones, and the future workforce will need to adapt to the changing landscape by upskilling and reskilling. We have an ethics board in ONS, which comprises several independent experts to reach out to key players in this field, such as the Alan Turing Institute and a whole range of universities, to share our experiences and talk through issues. Having a peer-to-peer network such as this is invaluable, and they do act as credible voices in this space. Here you'll notice that the Alan Turing Institute recently intervened into an online debate about whether a family of large language models developed by Google had developed feelings, clearly stating that they had not. So moving on to the triggers that might put AI use outside of tolerance, I kind of bucket these into three areas. So the first is kind of legal and regulatory. New legislation can impose restrictions and requirements. Stakeholder trust and confidence. We've discussed the potential for bias and unfairness in AI-generated content, which can lead to ethical dilemmas. The generative AI can sometimes produce incorrect or misleading information. Transparency and explainability. It will all depend on your appetite around stakeholder trust and confidence. And thirdly, the user behavior and the security risks. Just briefly to share where we've taken an appetite-based decision. So the Data Science Campus investigated if a version of ChatGPT could be used to find and retrieve the right parts of an ONS bulletin for the user. We developed a new semantic search to help with this, with significant guardrails in place, including separately verifying that the output was a direct quote of ONS and not displaying responses if no relevant web pages could be found, because prompt injection and hallucination were two of the biggest risks when developing this pilot. Now, when we've gone ahead and we've developed the chat, what we've termed Stats Chat, using a version of ChatGPT, the embedding search did show quite a clear improvement upon the current website performance in terms of picking out relevant sections of web pages from the user query. It was particularly effective at retrieving information for very specific queries. But overall, we deemed that the user experience was a top priority for us, and we couldn't risk presenting information and statistics to user queries that were potentially irrelevant, offensive, or politically sensitive. It was just too sensitive given the overall context and how our data is used. So we have currently paused this this pilot in terms of any implementation in ONS. So overall, 2025 is all about those decisions and working out what pilots can move from pilot into production. And there's a whole range of factors to take into account with this kind of decision making, including funding, governance, and overall fit with an organisation's purpose, goals, and priorities. Do you have the funding and resources to move forward? Does the pilot meet the best value for the organisation? It's really positive using generative AI for business process efficiencies, but is this really the best value that you can gain from it? What commercial considerations are there? The market still remains fairly immature. Reliable partners and stable prices are still to be established. And do you have a clear business sponsor that's going to drive through the change needed? We've recently published an update to the Magenta book around the evaluation of AI use within statistics. And we'll be happy to kind of share that link after the webinar. And we're increasingly working on identifying our value tree proposition as the resources and skills are to be used in the most value-adding way possible. So there is also a broader question around how official statistics stays relevant in the age of large language models. So we absolutely need to stay focused on services that large language models cannot do by themselves alone, providing high quality, accurate and timely source of choice options for our users, which means maintaining a strong hand on knowing about our data. So we see large language models and generative AI as key enabler, but certainly not taking over. And we need to be absolutely mindful of the market immaturity and the need to fix the data foundations first before embarking on the journey. I hope you've enjoyed listening. Thank you very much indeed. And now we've got plenty of time, I hope, for questions. So back over to Eleanor. Thank you.
Thanks so much, Fiona and Sarah. Really interesting presentations. And thanks so much to everyone for taking part in those Slido interactions. Some really interesting answers coming through. We're going to move on to our question section for the rest of the event. And we've had lots of great questions coming through. So thank you very much to everyone for putting those through. We will be answering the most popular questions first. So please do give a thumbs up to any of the questions you really want speakers to answer. If we don't have time to get to your question today, the ONS Engagement Hub inbox is always open. So please feel free to get in touch with us at engagement.hub@ons.gov.uk. This email address will be shared after the webinar. So let's get through to some of the questions. So the first question is from Joshi, thank you. Is there an approved ethical framework which public sector organisations like NHS follows when it comes to applying AI tools to sensitive data sets, such as health data sets? If yes, is that in the public domain? So I think, Sarah, that's one for you.
Yeah, I can answer that. The position of the NHS is very similar to what Fiona has shared on the ONS. So we do have policies in place for use of AI. I will have to confirm whether that's shared in the public domain, and if so, we can get the links to those. But we certainly do have those in place, and it is an evolving situation like it is with the ONS. But I mean, it's a huge privilege to be able to collect this information. It's obviously very sensitive information. And so we work to incredibly comprehensive information governance guidelines, and the security of the data is paramount. So yeah, I'm not sure where the public links are, but we'll share those after the call.
Lovely, thank you. The next question is, at the ONS, most statisticians have been enthusiastic about the potential of generative AI, and has there been more caution due to the potential of hallucinations or inaccuracies?
Thanks. I mean, it's difficult to talk for most statisticians. I think it's fair to say that we see the opportunity in the use of AI, and we have been actively pursuing a number of pilots. And we have been applying our knowledge and learning to understand where that kind of risk appetite lies. So I wouldn't say that there has necessarily been more caution. We're absolutely kind of working through the opportunity.
Lovely, thank you, Fiona. The next question is, can you say a bit more about the way you use AI? Is it through off-the-shelf products like Copilot, or by incorporating a proprietary large language model into a project via an API, or an open source model, or do you train your own?
Yeah, so we're not going to be in the market for developing our own large language model. So even like training that is going to be too expensive, and I think we're finding through our current piloting that it's it wouldn't be worth the investment, that existing off-the-shelf tools fulfill the purpose. So yeah, we do absolutely use we use the Google and kind of Amazon suite primarily. We are not really using any proprietary large language models at the moment, but we are using quite a bit of our own data to help with fine-tuning. But we're not necessarily seeing a massive uplift in quality from the fine-tuning, although again, it's so specific on the use case. But I think, yeah, our kind of broad view is that off-the-shelf products are good enough.
Lovely, thank you. The next question is from Alfie. What, if anything, does the recent announcement of the Humphrey suite of tools coming out of the Department for Science, Innovation and Technology, or A.IA, and its intention to be tools for all of the civil service mean for creating our own ONS AI or large language model tooling over time?
I'm actually not familiar with the Humphrey suite of tools, so I'm going to have to take that away and look at that. But I think we certainly sign up to a view of finding kind of common platforms which are scalable for broader kind of usage. And we've been doing quite a lot of work at the ONS to develop a new analytical platform called the Integrated Data Service, which is based on the Google infrastructure, elements of which we think are potentially scalable, and of which there's a kind of AI offering within that, subject to cost and priorities and so on. But let me take that away and we'll provide a response on the impact of Humphrey specifically.
Thanks, Fiona. Alfie, I would recommend if you could get in touch with Engagement Hub, we'll make sure that question is answered to you. So this might be one for both of you, but I am concerned about the amount of electricity it takes to run these models. Any comments on the cost benefit of this?
Yeah, you go first, Megan. Go on.
I think that's a very fair question. It is significant, and you would have noticed in the opportunities action plan that it touched on the building out the kind of power supply needed to help store and process the data. I haven't seen a cost benefit analysis of that, but I would suspect that there is some investment needed to ensure that we can use AI to its maximum impact.
Lovely, thank you. Next question, it's gone to the top. So would you be able to share if there are any challenges that you had to overcome regarding data sharing? I've heard the different NHS trusts are on different systems. Will this be a spread to devolved nations as well to get a complete picture?
So within NDRS, we have a legal basis to collect this information from direction from the Secretary of State, and that's for the purposes that I outlined at the beginning around supporting direct care and improving population health, surveillance, planning and commissioning. So because that is in place, we are able to data share within the NHS. And researchers can access our data through the Data Access Request Service at NHS England. We also do have agreements with devolved nations for disease registration, and because obviously patients cross those borders, and so we share data on those patients as well. The NHS in England is working on the federated data platform that will enable greater data sharing across the NHS, because you're right, there are different NHS systems for each hospital trust. As I mentioned at the beginning, some hospitals will have a different laboratory system, a different maternity system, and a different inpatient system as well. So the federated data platform is a way of trying to enable some of the challenges that creates.
Lovely, thank you, Sarah. I think we've got time for 2 or 3 more questions. So the next one is accountability. Who is responsible when an AI tool makes a mistake? has the NHS developed an accountability framework for the example provided?
So I would say that I'm accountable as the service lead for NDRS on this use, and that's why we do need to make sure that not only are we that we are focusing the use of our AI into those areas where we think it's going to have greatest impact and also greatest accuracy, and that's what we're doing very, very carefully. So everything that we're testing and exploring now is with clinicians and registration staff, checking and verifying that use. So I do think it's us as service providers that need to take that responsibility about its use, and doing a lot, as Fiona mentioned before. I do see this as alongside human intervention, so that it's working hand in hand.
Great, thank you, Sarah. I'll do a few more. So the next one is, do the ONS support the idea of standard synthetic data sets? Would this reduce carbon footprint of training AI, particular large language models?
I think yes, we would support the idea of developing synthetic data sets, which can be used to help improve the quality. I think in terms of reducing the carbon footprint, no, it would actually increase the carbon footprint, because you're effectively creating new content, I think, with that standardized synthetic data set, if that kind of makes sense. So whilst you have a reusable synthetic data set, it's actually continually creating new content in terms of how we're using that, which is the big environmental question around the use of generative AI.
Great. Thank you, Fiona and Sarah. With 1 minute to go, I think that's all the questions we have time for today. So please get in touch with us at engagement.hub@ons.gov.uk if we did not get to your answer today. But I'll finally just finish on a few bits with how you can get involved going forward. So obviously you can attend more of these events in our series, and you can follow official statistics producers on social media, whether that's LinkedIn, Instagram, X, or other platforms you use. You can also respond to consultations and engagements, which are the opportunities for us to really understand what user needs are for our outputs. And lastly, if your household is ever selected for a survey, we really value your time and responses so that we can gather meaningful data across the UK. So I'll just end on saying thank you very much to Fiona and Sarah for your presentations. It's been really interesting. We do have a feedback form for everyone who's attended today. So if you would like to take the time to scan the QR code and answer some questions on Slido, we'd really appreciate it. But thank you everybody for joining us today, and have a good evening. Thank you.